So continue to talk about the binary number, we want to talk about the binary addition. So actually for all the number addition, they are all similar. So we just see, for example, in the decimal world, yes, in our human world, how did you do the addition? So for example, I have 1, 2, 3 plus, yeah, because here I need to have some space. Okay, so 1, 2, 3 plus 8, 9, 1. Okay, so how you will do the addition? So how you do the addition, actually just start from the most right? So then 3 plus 1 is, yeah, we need to, yeah, because I cannot write from here. But we do the 4 first. So then 2 plus 9 is 11. So then you add 1 more, 11, to carry to the front. So that's why here you see, when you do the decimal addition, you use the most least significant bit. So you start from the right-hand side. So 3 plus 1, 4. 2 plus 9, 11. So you carry over 1. So then you have 10. So right, the same thing. Binary do the same thing. You still found the most right digit. That's what we call the least significant bit. But then each pair of digits is just added together. So then you see here, start with the least significant bit. You add each pair of the digit. So if you need to carry over to the next bit, you can do that. So here we have two binary numbers. So this 0, 0, 0, 0, you see we do the 1 byte, 0, 1, 0, 0. This number actually equivalent to the decimal number 4. So this number 1, 1, 1 is 4 plus 2 plus 1. So decimal value equal to 7. Right, 4 plus 7 equal to 11, right? So here we just want to prove to you, after you do the binary number addition, the value will be the same. Okay, so now we do the binary addition from here. So you see most least significant bit. 0 plus 1, 1. 0 plus 1, 1. But 1 plus 1 is what? Right, 1 plus 1 is 2. Do we have 2 in binary system? No, right. So every time when you have 2, that means you need to carry over the 1. Because when you carry over this 1 to the next one, the value, they will change, become the next value, next digit value. So that's why when you see 2, right, so you carry over 1. So 2 become 1 to the next digit. So here we put a 0. So then you have 1. So 0, 0, then you do the 1. So then you finish. Okay, so remember, be careful. In binary system, when you have 2, you already mean you carry over 1 to the next value. Because we don't have 2 in the binary system. Just like this one. 1 carry over 1. So 1 plus 1 plus 8 is what? Is 10. Right, so 10 is what? 10 doesn't write in this bit. In the 1/8 bit, they need to carry over 1. So then you have the 10. But just in the binary system, because we only have 2. So your 1 plus 1 become 2, right? 2 actually just means the next digit they have carry over 1. So then that's our result. So after you have 1, 0, 1, 1, did you see? This one value is 0. This one 2 to the 1's power, 2 to the 0's power, 2 to the 1's power, then 2 to the 2nd's power, 2 to the 3rd power. So this one is 8. 8 plus 2 plus 1, so they are equal to 11. So that's how we do the binary addition. So check to make sure you also write by yourself to understand how to do that. Next one, let's introduce what are hexadecimal. Earlier we introduced binary number. That's because you need to understand in computer system how we save the value in the 1 and 0 bit environment. So that's why you need to understand the binary number, how to do the calculation and how they look like to store the decimal value. But a lot of time also we need to use the hexadecimal for the representation. Hexadecimal is not really we store in the computer. Hexadecimal actually can be used to represent a bigger number. For example, our memory address. So that's why we have the hexadecimal you also need to understand. So what is the hexadecimal? Hexadecimal represents 16. So earlier when we talk about binary number, you only have 1, 0. Decimal numbers start from 0 to 9, right? So hexadecimal, you have 1 bit contains 16 different values. So we start from 0. Since human only understand until 9, right? So in order for the hexadecimal have 0 to 9, then we're using the A, B, C, D, E, F. A represent decimal value 10, B 11. So that's why we say here you have 0 to 15 using the hexadecimal to represent 0 to 15 from using the 0 to the F. So total you have 16 different values. So this table you can easily to see the comparison for the same value, right? Because human we understand decimal value, so we write here. When decimal value is 0, binary, right? Usually binary we're using 1 byte, but here we're using 4 bits only. Why? Later I will explain to you why we do this way. So then here, decimal equal to 0, you're using 000, 4 bits. Hexadecimal actually the same thing using the 0. Decimal number value is 1, so your binary will do 0001. So hex will be the same. So that's why you can see from decimal number 0 to 9, hexadecimal actually represent the same thing. But just start from 10 to 15, we're using the A to F to represent. So now come back to see here why we only show you binary 4-bit here. Because any 4-bit binary represent a 1 hexadecimal value. Why? Because you see here, when you have 4 bits in binary, that means 4 bits to the binary, you have 0, 0 is the smallest one, right? If we only have 4 bits. So then the biggest value will be this 4 bits. They are all 1. So that's why you can see here. 0 represent like this. Then 1, 2, 3, 4. So then 15 represent 1, 1, 1. So on the other hand, this is how the hex convert to decimal. And every 4-bit binary equivalent to 1 bit hexadecimal. So that's the table we can see from here. That's the relationship between how to convert binary number, decimal number, and the hex number. So that's why when you translate binary number to hex number, actually it's quite simple. Whenever you want to convert binary to hexadecimal number, you just need to using each hexadecimal number corresponding to 4 binary number. So 1 hexadecimal equal to the 1 binary bit. Okay, so that's how it will change. So that's why here, when we have a big number, 1 byte, 2 byte, 3 byte, this number, you can see because they only have 0 and 1, right? So we know this 3 byte value binary number. If we want to convert to the hexadecimal, what you need to do, you just do 4, 4, and the 4. So each 4 bit represent 1 hex system. So here 1, yeah, of course 1 equal to 1 hex. But here you see you have 0, 1, 1, 0, right? So that's 4 plus 2 is 6. So that's why hex is 6. So here you have 8 plus 2 is 10. Yeah, but the 10, we don't using the 10 for the hex. So that will be A. Then here you have 4 plus 2 plus 1, that's 7. So hex just using 7. So 8 plus 1 is 9. So then here is 4. So this 3 byte binary number, when you convert to the hex, their answer is 16794. Usually we do this way. You can make the space because one thing is every 2-bit hex number represent 1 byte. So that's why sometimes you can write byte by byte like that. But if we want just connect to each other, it's okay. Just you're using 1 byte, byte by byte, it's easier to read. So that's how to convert binary to hex. On the other hand, if you have a hex number, convert to the binary will be the same, just using one hex number to represent in 4-bit value. So let's continue to talk about hexadecimal number, how to convert between the decimal number. So you will see they will be the same. Decimal number base is 10, binary number base is 2. So hexadecimal number base is 16. So that's why when you're using the value, you just need to do the digit value that's equal to the decimal value. So then you just need to multiply 1 by 1. So for example, here I have a hex code. Hex number is 1, 2, 3, 4. But here the 4 represents 16 to the 0th power. These 3, the digit value will be 16 to the 1st power. So the same thing, 2 will be 16 squared. This one is, the 1 is 16 to the 3rd power. So you just need to using the bit to multiply the corresponding bit value. So that's why 1 times 16 cube, 2 times 16 squared, 3 times 16. Then 4, 4 is 16 0 squared. 0 power, that will be 1. So this one you need to use calculator. So after you add together, right, that's their decimal value. Yeah, so this one is how you convert from the hex to decimal. You're just using the digit value times digit. And the digit in that position times digit value. So now, of course, we have the exercise for you here. So you can post a video and try to convert this number, hexadecimal number, into the decimal number. Then you can check the answer. So check the answer and make sure you understand how to do that. So earlier we talked about hex to decimal. So of course now you can do the decimal to hex. So the decimal to hex, just like decimal to binary, we need to using division. But for the decimal to binary, we divide to 2. Here we divide by 16. So if we want to convert decimal number 422 to hex, so what you do is you divide by 16. Then you have quotient. Then you have remainder. So remember, remainder will put in the from the right to fill up. So then again, quotient divided by 16. Remainder is 10. Yeah, here we say A, but that's 10, right? But 10, we cannot put the 10 for the hex number, so we put the A. So then continue, 1 divided by 16, remainder is 1. So that's why your remainder start from 6A1, but we fill up start from right. So that's 6A1, that's 1A6 for the decimal number. Pause the video anytime to make sure you understand. So this video, I only have 1 minute something left. So we just quickly go over the addition. So you will see addition, the same thing. We always line up the same digit. Then we start from the number to add from the right. So here you have A plus B. So A is 10, B is 11. So 10 plus 11 is 21. So 21, we need to carry over 1, right? Then, because this one is the hexadecimal number, the 1 you carry equivalent to 16. But here, A plus B is 21. So 21, after I carry over 1, I give them the 16 to the previous one, right? So then you just do the 21 minus 16. So that's why you have 5 left. So that's why we put the 5 here. So then 1 plus 6 plus 4 is 11. So that's B. So 8 plus 8 is 16. Here, 16 we carry over 16. So that's why we have 0 left. So 1, 2, 5 is 8. So then 8 plus 5 is 13. But 13 is D. So then don't carry over. So 2 plus 4 is 6. So 6 plus 2, 8. 3 plus 4 is 7. So that's how you will do the addition. So you can see binary number, decimal number, hexadecimal number addition is the same. Just carry